a triangular similarity. So I'm just going to draw a triangle here. And over here we'll draw a small triangle. Okay, so let's pretend for a second that these two triangles both have angles of 60 degrees in the corner, okay? I know these aren't quite 60, but let's imagine, okay? So both these triangles have two angles at the bottom that are 60 degrees. As you might recall, the three angles of a triangle have to add up to 180, okay? So since they both have two angles that add up to, or that are 60, and you combine those, you get 120, that means that the third angle up top here must be 60 for both triangles. And we'll call this one ABC. We'll call this one DEF. Now, as it turns out, in a triangle, if you have two angles, say angle B and angle E, and angle C and angle F, the two bottom angles for both of these, if those two angles are equal to each other, so the corresponding angles, B corresponds to E, C corresponds to F, by definition, the third angle, angle A and angle D, has to also be equal. And if all three angles are equal, now remember, and we call this, I'm going to call it AA, because if two angles are equal, then by definition, the third angle is equal, and also automatically the three sides are going to be proportional, so or produce the same scale factor. So we can either compare 30 to 30 and 10 to 10 to get 1, or we can compare 10 to 30 and also get 1/3, okay? So ABC is 3 times larger than DEF. So essentially, if you're going to prove that a triangle is similar, one way you can do it, and this is why I've put it in parentheses, brackets here, is that you only need to prove that two corresponding angles, in this case angle B is equal to angle E, angle C is equal to angle F, and if two angles are equal, then automatically the third angle, A, will be equal to D, and also the three sides will be proportional to each other. So one way you can prove triangle similarity is to simply just prove that two corresponding angles are equal. Well, you might ask yourself, what about if you automatically prove that three sides are proportional? So in this case, DE is 1/3 of AB, EF is 1/3 of BC, and DF is 1/3 of AC. Now, in this case, it's not enough to prove that two sides are proportional, corresponding sides. You have to prove that all three corresponding sides are equal. And if that's the case, then automatically the three corresponding angles, when it comes to sides, you need to prove that they're proportional, and when it comes to angles, that you prove that they're equal. So I'm going to put this in brackets because unlike with the angles where you only have to prove that two angles are equal, with the sides you have to prove that all three sides are proportional, okay? And then people ask, what about side angle side? That is true. If you have a side, say BC, that is proportional to EF, and then angle C is equal to angle F, and AC is proportional to DF. So, the reason why you call it side angle side is that there's an angle right here that's in between two sides. There's an angle in here that's in between two sides. So if you prove that an angle has the same measure, say angle C has the same measure as angle F, and that the two sides that are surround it are proportional to the corresponding sides on the other triangle, then by definition, the remaining side is going to be proportional and the other two angles will be equal. So again, I'm going to put that in brackets, and you could probably look at another one where it's ASA. So you have an angle or a side that's proportional, say BC, that's between two angles, B and C, that are equal. Of course, in this case, you should be able to realize that ASA, or angle side angle, proves triangle similarity because it has the two angles in it that are equal. And remember, if you go back to the first one up here, as soon as you have two angles that are equal, by definition, the third angle will be equal and the three sides are proportional. If you prove that three sides, corresponding sides, are proportional, then automatically the three corresponding angles will be equal. If you prove that an angle is equal to its corresponding angle, and the two sides on either side of that angle are proportional to the corresponding sides on the other triangle, then you've also proven triangular similarity. And finally, ASA, angle side angle, recognizing that you really only have to prove AA. Okay, so there you have it. You can see that it's a lot easier to prove triangular similarity. When you're dealing with polygons, you have to prove that all corresponding sides are proportional, and you also have to prove that all corresponding angles are equal. Whereas with a triangle, you can see in the easiest case, you've got, if you prove that two corresponding angles are equal, either in AAA or ASA, then the triangles are similar. If you prove that three corresponding sides are proportional, then automatically you have a similar triangle. And same thing with SAS. So you've got basically four options here, and remembering that two of them, you literally only have to prove that two corresponding angles are equal, AAA and ASA. All right. So I hope that's helpful. What I'm going to do now is I'm going to go back and do a video on actually solving a problem that involves polygonal similarity, and then do another video where I solve a problem that involves triangular similarity. But to sum up, it's a lot easier to prove triangular similarity. All you need to do is show that, say, two angles B and C are equal to two corresponding angles E and F, and then you know that the triangles are similar. You could also prove that the three sides AB, BC, and AC are proportional to DE, EF, and DF. In this case, they produce a scale factor of 3 or 1/3, depending on which way you go. And again, side angle side works, and angle side angle. Okay, talk to you later. Bye.